Hello everyone, I'm Sheetal Nagar, faculty of BTech EC department, working as assistant professor at IIMT Group of Colleges, Greater Noida. Today, I am going to introduce the operational amplifier. Operational amplifier is an amplifier which provide us a very high voltage gain. First of all, we introduce the operational amplifier. As we already know, we require a very high gain for the circuitry. So with the help of this amplifier, we get a very high gain and able to amplify signals with frequency ranging from 0 to 1 megahertz. An operational amplifier is named so because it was originally designed to perform mathematical operations like addition, subtraction, multiplication, and differentiation, integration, etc. for the analogous computers. It has two input terminals. First one is inverting input, which is represented by minus sign, and next another one is non-inverting input, which is represented by plus sign and one output terminal. A complete amplifier circuit may contain transistor, diode, resistor, capacitor, and other components which construct a on a single silicon chip, that is integrated circuit. Also, the area of this is 5 mm square and thickness for this is less than 0.5 mm. It is protected by the plastic. Now, this is the symbol of operational amplifier. In figure 1, we are showing the symbol of operational amplifier, which is shown by a big triangle and which have two inputs. One is the inverting input, which is represented by a minus sign, and another one is non-inverting input, which is represented by plus sign also, and it has one output terminal and two terminals for VCC and ground. Sometimes we can show by the plus VCC and minus VCC also. In figure 2, this is the pin diagram for 741 operational amplifier IC. Pin 1 is used for the offset null. Pin number 2, which is used for input for inverting input, and 3 also used for non-inverting input, means pin number 2 and 3 used for input to the operational amplifier as indicated inside the IC also, and pin number 4, which is used for the ground or negative VCC. Pin number 5 is used for offset null. Pin number 6 is used for output pin, and pin number 7 is used for positive VCC or positive voltage supply, and pin number 8 for not connected pin. Basic principles of operational amplifier. Basically, operational amplifier has two inputs, inverting and non-inverting. We have two modes of operation for the operational amplifier. First one is the differential mode and second one is the common mode. Now we first of all we discuss the differential mode. In this mode, we can apply the signal on a single input signal, which can be inverting or non-inverting also, and another one will be the ground, and we will apply only input voltage only at one pin. This is single input signal applied at the negative terminal will appear amplified in phase inverted at the output as shown in the figure. Means if we are applying an input signal voltage at inverting input, then at the output we will get the we will get the output which is 180 degree with 180 degree phase shift as shown in the figure also, but in the amplified manner. At that time, non-inverting input is ground. Now, non-inverting input terminal is now applied at input voltage signal as shown in the figure, and at that time inverting input signal is ground. In this case, the output voltage or output signal will be in the stage of the input signal, but in the amplified manner. Means our signal will be amplified, but in phase only. In this case, there are no 180-degree phase shift at the output terminal. In this case, signal applied at positive input terminal, which will appear and amplified and in phase at the output terminal, and output loop voltage gain, which is represented by AV, is equal to VO, that is output voltage oblique VID, where VID is the voltage different on inverting input and non-inverting input. Now, input signal mode. Again, now in this figure, we are representing the input signal in the form of a sinusoidal sine wave, and in this in single-ended input mode, one input is grounded and signal voltage is applied only other input. If the input is applied to the non-inverting terminal, the output signal will be in the same phase with the input signal, as shown in figure also. In this case also, we applied at input voltage as shown in figure. In this case, we are applying a sinusoidal voltage at inverting input, and we will get the output with 180-degree phase shift for the sinusoidal signal also. Now, this is the case for the double-ended differential input mode, and the differential input is amplified and in phase with the input signal also. In this case, we will apply the input signal at both inverting and non-inverting input terminals, and will get the amplified output voltage. Now, this is the block diagram of operational amplifier. Basically, operational amplifier block diagram contains 3 stages: first stage, second stage, and third stage. Now, an operational amplifier is a high quality amplifier. It contains 3 stages which are connected in cascaded manner. Though designs vary between products and manufacturers, all operational amplifiers have basically the same internal structure, which consists of 3 stages. At the first stage of an operational amplifier, a differential amplifier, which is double-ended, it provides a very low noise amplification and high input impedance. Means this is the main characteristics of operational amplifier. Means input impedance must be high. And in case of ideal operational amplifier, input impedance must be infinite, usually a differential output. The second stage of an intermediate gain stage, voltage amplifier provide a high voltage gain, usually single-ended output. And the third stage is an operational amplifier stage, which provide low output impedance, current limiting, and short circuit protection circuitry. Now, this is the block diagram of operational amplifier. In this case, we are showing the main blocks of operational amplifier, and in this operational amplifier, we use different amplifier, differential amplifier, voltage amplifier, output amplifier, and the input and non-inverting input also. Now, input bias current. These are the main parameters of the operational amplifier, in which it is the most important parameter, that is input bias current. The average of the current flowing inputs, it can be calculated as follows, that is input bias current is equal to I1 plus I2 oblique T, where I1 is the current flowing through the V1 and I2 is the current flowing through the V2. The concept of input bias current is illustrated ahead. The difference of two input currents when the output voltage is zero. The concept of input offset current is illustrated with the help of this diagram also. In this diagram, I1 and I2 is showing and flowing through the I1 are in means two different internal resistance. Input impedance of the uh, operational amplifier must be very high. Now, input offset voltage. This is another parameter of operational amplifier. A small DC voltage appear at the output when no differential input voltage applied. Its primary cause is a slight mismatch of the base emitter voltages of the differential amplifier input stage of an operational amplifier. Typical values of input offset voltage are in the range of 2 millivolt or less. In the ideal case, it is 0 volt. Common mode gain. Now, this is the another mode to bias the operational amplifier, give the input of operational amplifier. Common mode gain. In this case, we apply the same input signal at inverting and non-inverting both input terminals and get the output. Same voltage source is applied and output voltage is ideally zero. If we talk regarding the ideal characteristics of an operational amplifier, so in this case, it must be zero. Differential voltage of the operational amplifier must be zero. But practically, this is not possible. Practically, a small amount of voltage, a small output signal can still be measured. Now, the most important parameter of the operational amplifier is the common mode rejection ratio, CMRR. The common mode rejection ratio is the measure of the device ability to reject common mode signals. It is the ratio of open loop gain, AOL, to common mode gain, which is represented by ACM. Hence, CMRR, that is common mode rejection ratio, is equal to AOL oblique ACM. The CMRR is often expressed in decibels as CMRR is equal to 20 log AOL oblique ACM, and with common devices having ratings between 60 dB to 120 dB. The higher the CMRR, the better the device. In case of ideal operational amplifier, the CMRR must be infinite also. Now, again, we come at the internal block diagram of the operational amplifier after discussion of the some important characteristics of operational amplifier. We will look which kind of amplifiers and which kind of amplification we use at the different stages. At input stage, we use differential amplifier. What is differential amplifier? An operational amplifier is usually matched transistor configured as a dual input differential amplifier. Output of this input stage taken from across the output collector. We take the output at the collector of the transistor of the paired transistor. Okay, this balanced output is fed into another dual input GA in the intermediate stage, that is gain stage. Again, we send the amplified output to the gain stage. In here, we use a voltage amplifier to the gain, more gain of operational amplifier. The output of this intermediate stage is taken from just one of the transistors, single-ended. The DC level at the output of this stage is high with respect to the ground. So a level shifting circuit such as the emitter pullover is used to shift it down closer to ground. Now, next and last stage of our is that is output stage. At output stage, we use push-pull amplifier. This push-pull amplifier acts as a buffer to connect second level and the output differential amplifier not affected by the load. Now, it consists of a push-pull amplifier which increases the swing of the output voltage and enhances the load current capacity of the operational amplifier. Now, we just talked regarding the parameters of operational amplifier. But if we talked ideally, which kind of operational amplifier must be and which kind of characteristics it must have, this is the most important topic of operational amplifier. That is ideal characteristics of operational amplifier. The first one is the voltage gain of the ideal operational amplifier must be infinite. The gain of an operational amplifier without positive or negative feedback. Ideal operational amplifier is taken to infinite value. Typically, the range of this value is 20,000 to 2 lakhs in this real devices. Means it's very high, but ideally it must be infinite. Now, next one is the input impedance. Again, this parameter, this characteristics of ideal operational amplifier, it must be infinite, which is represented by Z in, which is equal to V in, that is input voltage oblique input current. Means ideally Z in or input impedance must be infinite. Now, next one is output impedance. For the ideal operational amplifier, it must be zero, but practically this is not possible and it also have some value. An ideal operational amplifier has input impedance, infinite input impedance and zero output impedance. When IE in is zero, if R in is equal to infinite, we show this output impedance through a model of an operational amplifier. If the output resistance RO is very small, there is no drop in voltage due to the output resistance of an operational amplifier. Now, next characteristics of ideal operational amplifier is input offset voltage. It must be zero. Again, practically this is not possible. Input offset voltage of an operational amplifier is equal to the output for the zero, which is VOS is equal to VO oblique AOL. Output voltage of an operational amplifier should be zero when the value of an applied voltage at both the input terminals is zero. Practically, operational amplifier found the output voltage that exists for zero input voltage. It caused by a small imbalances within the operational amplifier. Now, next characteristic of operational amplifier is offset current. It must be zero. Offset current of operational amplifier must be zero. But ideally, practically, this is not also possible. Now, last one and most important characteristics of ideal operational amplifier is the bandwidth. The bandwidth of the ideal operational amplifier must be infinite. The bandwidth of an operational amplifier is the range of frequencies for which the amplifier gives satisfactory performance, as shown in figure also. Now, comparison of operational amplifier characteristics. For the ideal operational amplifier, real characteristics. Ideally, we discussed all the characteristics of operational amplifier, which has infinite open loop gain, infinite input impedance, zero output impedance, perfect balance, zero offset voltage, zero offset current, infinite bandwidth. But practically, this is not possible, and we have real characteristics for these parameters also, as shown in the comparison table. For the open loop gain, input impedance, low or output impedance, and perfect balance is also not possible. Minimum offset voltage and minimum offset current and bandwidth also. We have limited limits for our ideal characteristics as shown in the real characteristics parameter. Thank you.